Dear Tim and Moby, what's temperature? From Zach. All the matter in the universe is made out of tiny particles called atoms, which can be combined into slightly larger particles called molecules. Atoms and molecules are on the move all the time. All this molecular movement creates heat energy. Temperature is a measure of heat or how fast those molecules are moving. The more you heat something, the faster the molecules move. This is what causes its temperature to rise. There's really no such thing as cold. Cold is just an absence of the molecular motion that causes heat. Boiling water has a higher temperature than cold water simply because its molecules are moving around more. Temperature is measured using a thermometer. There are three main scales by which temperature is measured. The Celsius or centigrade scale is the most widely used, and it's based on the behavior of water. Water freezes at 0 degrees Celsius and boils at 100 degrees Celsius. The Fahrenheit scale, used primarily in the United States, is a little less straightforward. Pure water freezes at 32 degrees Fahrenheit and boils at 212 degrees Fahrenheit. The Kelvin scale is a favorite of scientists because it begins at the absolute coldest anything can get. This temperature is also called absolute zero, and it equals 0 kelvins. At absolute zero, all molecular motion stops. There's always some molecular motion, so you won't ever actually see absolute zero. Deep space gets close, but even there, the cosmic background radiation from the Big Bang keeps things slightly above 0 kelvins. More temperature stuff? Heated gases expand, making them less dense. Air near the Earth's surface is heated by sunlight striking the ground. This warm air rises, and cooler, denser air from higher in the atmosphere sinks down to take its place. The warmer air cools off, and the cooler air warms up, creating a convection current. That, along with the rotation of the Earth, is where the wind comes from. When matter heats up, it has a tendency to expand. This is how thermometers work. A liquid, like mercury, is sealed in a glass tube. Heat makes the molecules of the fluid move more rapidly and expand. The liquid rises, showing us the temperature. Why?
Full-time Kid with Maya. Hi, Maya here. Today we're going to make our own thermometer. Here's what you'll need. An empty glass bottle, some food coloring, some modeling clay, a clear straw, 1/2 cup of rubbing alcohol, and 1/2 cup of water. Pour your water into the glass bottle. Now pour your rubbing alcohol into the bottle. Add a few drops of food coloring. Now mix it like this. Insert your straw into the bottle. Make sure it doesn't fall through or touch the bottom, just like this. Now squish your modeling clay around the straw. Make sure not to cover the top of the straw. The liquid expands when it's warm and moves up the straw. The liquid contracts when it's cold and moves down the straw. Put your thermometer in the sun if you want to see it in action. Let's go check it out. Whoa, that's cool! Science is awesome. Thanks for watching. Pour your water into the glass bottle. Glass bottle.
One more time. Ready?
Okay, I have a confession to make. I've lived in the United States since 2010, and
Alexa, what's the weather today? Right now in New York, it's 65 degrees with clear skies and sun. Today's forecast has partly sunny weather, with a high of 77 degrees and a low of 61 degrees.
I still don't understand the use of Fahrenheit. Virtually every country on Earth uses Celsius to measure temperature, but the US still uses Fahrenheit. And for that reason, we at Vox often get comments like these. Okay, we get it. Besides the fact that the majority of the world uses it, the metric system makes conversions a lot easier. The Celsius scale even looks simpler. It has freezing and boiling points at nice round numbers, 0 and 100, where in Fahrenheit, it's a bit of a mess. And of course, this isn't just an issue of aesthetics or weather updates. America's unwillingness to switch over to the metric system has had serious consequences. In 1999, a $125 million satellite sent to Mars disappeared in the Martian atmosphere.
It's a setback to years of work already done. In the vastness of space, all it takes is one navigation error.
And this colossal mistake was largely due to a conversion error between US and metric measurements. Fahrenheit was really useful in the early 18th century. At the time, no one really had a consistent way to measure temperature. But then a German scientist came up with the Fahrenheit scale when he invented the mercury thermometer in 1714. To make this scale, the most popular theory is that he picked the temperature of an ice-water-salt mixture at the 0 mark. He then put the freezing point of water, which is higher than a salt mixture, at 32, and placed the average temperature of the human body at 96. From there, he placed a boiling point of water at 212 degrees. In 1724, Fahrenheit formalized that scale and was inducted into the British Royal Society, where his system was a big hit. As Britain conquered huge parts of the globe in the 18th and 19th centuries, it brought the Fahrenheit system and other imperial measurements such as feet and ounces along with them. And Fahrenheit became a standard system for the British Empire across the globe. In the meantime, the metric system was gaining popularity during the French Revolution. It was put in place to unify the country at the national level. So by the second half of the 20th century, Celsius became popular in many parts of the world, when many English-speaking countries began using the metric system. Even America attempted to switch over. The change would have been good for trade and scientific communications with the rest of the world. So Congress passed a law, the 1975 Metric Conversion Act, which led to the United States Metric Board that would educate people about the system. This created the only metric highway sign in the US, the Interstate 19 connecting Arizona to Mexico, but it didn't go much further than that. The problem was that unlike the UK, Canada, or Australia, the law made the switch voluntary instead of mandatory. And of course, people resisted the change and the metric board couldn't enforce the conversion. So President Reagan ended up disbanding the board in 1982. The next nudge to Metricate came when the metric system became the preferred measure for American trade and commerce in 1988, but nothing really stuck with the general public, even though bizarre measurements like feet and Fahrenheit are not doing them any favors. Students have to train for 2 sets of measurements, making science education even more difficult. And companies spend extra dollars producing 2 sets of products, one for the US and the other for metric. There's also an argument for public health. According to the CDC, about 3,000 to 4,000 kids are brought to the ER due to unintentional medication overdose every year. And conversion errors for dosage are to blame. So it seems like a no-brainer. America needs to switch to the metric system to match the rest of the world, but it is still struggling to make that change. That's because it'll take a lot of time and money, but there's no financial proof that this will all be worth it. So unless that change is proven to be economically better, we're not going to be using Celsius anytime soon.
What's 77 Fahrenheit in Celsius?
77 degrees Fahrenheit is 25 degrees Celsius.
Ah.
Absolute zero is the holy grail of temperatures. But even though we know exactly how cold that is, negative 273.15 degrees Celsius, Reaching it has eluded us for centuries and will continue to elude us probably forever. For this frustration, we have to thank Sir William Thomson, 1st Baron Kelvin, who in the mid-1800s tested a new theory that heat is just molecules moving around in a substance. So he wanted to get stuff as cold as he could get it. So he conducted experiments that drew heat from a warm substance toward a cooler one and found that at some point, all the kinetic energy could be drained from the warm substance. It could no longer be cooled any further. This temperature wasn't like melting points or boiling points, which change for every substance. It was the same for everything. So Kelvin created a thermodynamic temperature scale that measured the amount of kinetic energy within any given material, and we still use his Kelvin scale today. But ever since Kelvin's day, scientists have been trying to chill stuff to absolute zero, and no one has succeeded. All a bunch of failures, because it turns out quantum mechanics is involved, which means it's really complicated. Physicists know that absolute zero does not mean a complete absence of motion in a substance. Instead, 0 degrees Kelvin marks the state of minimal motion of a substance particles. That's because of Heisenberg's uncertainty principle, which says that for any ever-loving particle in the universe, it's impossible to know both its momentum and its exact position at the same time. So suppose you chill a lump of lead down to the point where there is no motion going on within it, even at a subatomic level. If you could do that, you'd know both the particles' positions and their momentum, which would be 0. But measuring this is impossible. It's forbidden by the uncertainty principle, so it cannot be done. So you can't reach true 0 degrees Kelvin, but you can get pretty darn close, like a billionth of a degree away. And when you get that cold, some pretty weird stuff starts happening. Below about 30 degrees Kelvin, some substances can become superconductive, meaning that they carry an electrical current with no resistance, which is super useful when you're making particle accelerators or really powerful electromagnets to put in your MRI machines. And those superconductors have been discovered that operate at much warmer temperatures. The development of the field was thanks to work at very, very cold temperatures measured on the Kelvin scale. And you might be wondering, because I was, how cold is the coldest place in the universe? You'd think like deep space, right? Well, yeah, space is cold, but it's pretty uniformly filled with microwave radiation left over from the Big Bang. This actually heats up space to a balmy 2.73 degrees Kelvin. The coldest natural place in the known universe is the Boomerang Nebula, which has been spitting out gas for so long that it's cooled down to only about 1 degree Kelvin. And all of this means that, in fact, the coldest place in the known universe is in laboratories right here on planet Earth. Pretty cool. Thank you for watching this episode of SciShow. I hope that you got smarter. If you want to continue getting smarter, you should go to YouTube.